This conference will now be recorded.
All right. Well, hello, everyone. Thank you for joining me today. I know that everybody's very busy, so we're very thankful to have a crowd come in and listen to our webinar. As many of you know, my name is Emily Noakes, and I am SECOORA's Marketing and Communications Specialist. And I'm just going to give a brief intro to SECOORA and a little update before I turn things over to Dr. Liu to get into the webinar. So as many of you know, SECOORA stands for the Southeast Coastal Ocean Observing Regional Association, and we are one of the 11 regional coastal observing systems that make up the NOAA-led Integrated Ocean Observing System, or IOOS. So I do want to give a brief overview about the funding landscape right now. I know many of you have seen on social media, on news articles, about how NOAA programs are at risk, and SECOORA does fall under that in terms of our funding being at risk. So what exactly is going on? Basically, there was a leaked document from the executive branch that indicated the intent to eliminate the IOOS regional observations budget for next year. This document also indicated that NOAA should reflect these proposed cuts in this year's funding to IOOS regions, which is completely contradictory to the budget that Congress has already approved for this year. If these cuts are implemented, then SECOORA would have to begin shutting down operations in late summer, and this would include pulling assets out of the water. And this is obviously very important because SECOORA provides critical infrastructure that supports disaster preparation, economic stability, public health and safety, marine operations. The list goes on if you're familiar with SECOORA. So we just wanted to bring this to y'all's attention. We will be having some outreach materials floating out there very soon, giving you some information on ways that you can advocate for us and share how SECOORA data and our work in general is important to you and to your livelihood. So with that being said, if you do want to go ahead and show your interest in helping us out, you can send me an email, emily@secoora.org. We have some letter templates and some talking points that you can personalize and then share with your congressman. We can help connect you to the right office if you've never done this before and you're not super familiar with who you need to talk to and what the right avenue is for that. So feel free to just shoot me an email and then we can start the conversation there. So with that being said, we do have an update regarding our annual meeting. I'm sure many of you have seen that there have been some changes on our website and our communications about this meeting. So originally we were going to have the annual meeting in North Carolina on May 14th through the 15th. This unfortunately is no longer going to be in person. We are going to have the virtual meeting for this. We still want to get PIs and stakeholders and everybody together in order to discuss the current funding situation, discuss challenges and the impact of SECOORA operations moving forward, and try to brainstorm some ideas and solutions. But this will be on the virtual platform rather than in person. We thought that this was the most responsible thing to do, given some challenges that other folks are having in regards to travel. So even if you registered for the in-person meeting, we do need you to go ahead and register again. We will have that registration form going live today in order to kind of gauge your interest in what you're hoping to gain from this virtual session so we can make sure that it is as productive as possible, because we know that your time is super valuable right now. All right, so with that being said, I want to go ahead and introduce our speaker. Our speaker today is Dr. Yonggang Liu. He is an associate professor at the University of South Florida's College of Marine Science. He is also the director of the Ocean Circulation Lab at the USF College of Marine Science. As a physical oceanographer, he aims to better understand the coastal ocean circulation and air-sea interactions on the West Florida shelf including the exchanges of water properties between the estuaries, the shelf, and the offshore loop current system of the Gulf. His research team maintains a coordinated coastal ocean observing and modeling program focusing on the West Florida shelf and the estuaries. He is interested in applying the scientific research to marine environmental issues of societal importance, such as Carena brevis red tide tracking and seasonal prediction, hurricane rapid intensification, storm surge and coastal inundation forecasts, sargassum tracking, wastewater plume modeling, and oil spill tracking. So with that, I am going to turn things over to Dr. Liu so that he can start his presentation.
Thank you, Emily. I'll just share with my window. Okay. Window. Share. Oh, this is the last one. Yeah. Okay. Start from beginning. Good
Oh wait, we can't
afternoon.
see your screen anymore.
Sorry?
Your screen disappeared.
My screen disappeared?
Yeah.
Okay, let me share again. Sorry.
We saw it for a second, but then it did disappear.
Okay, share. Share my screen again, window. Okay. Now you see?
Yes, I do see it.
Okay.
Perfect.
Thanks. Good afternoon, everybody. This lunchtime, I will try to give a brief presentation. I won't take an entire 50 minutes. I'll try to do that. Yeah, the title is Rapid Identification of Hurricane Ian, the warm subsurface water on the wide continental shelf. I want to take advantage. Is the beginning of the presentation to thank all the funding agencies. The work, the sustained coastal ocean observing effort on the western shelf was primarily supported by SECOORA and IO's funding, and also we have leveraged through many other projects. So thanks for their support. Without their sustained support, it won't be possible to know all about this. Hurricane Ian was Category 5 hurricane when before it made landfall on the western shelf. And it intensified from Category 3 to Category 5 just within 1 day. So it's rapid intensification. So why did it rapidly intensify on this shallow water? You know, we had our graduate student Alex Nickerson that had part of dissertation had some research about the atmosphere part. Manuscript has been submitted to JGR Oceans. Still, it's revised but still under review. I won't talk about this today, but I will talk more focus on the ocean side of the story. Okay. So marine heat waves that have been talked about by so many investigators around the world, not only in here in the Gulf. The recent publication talking about that. I won't introduce more details here in this presentation, but I want to give you example what the current the ocean heat content with related with marine heat wave information. What this kind of product can provide to the western shelf. See, this is the product I copied from University of Miami website. It's a nice product, providing very useful information for hurricane heat content in deep water. But if you take a look at the western shelf, most of the western shelf don't have any useful information. And for even for outer shelf, there's just a small area have information, but it shows that heat content is very low. Of course, that this product need a better version for the coastal area, okay, particularly for the wide western shelf. So I'm going to let you know that, okay, this the topic in this presentation is focused on the subsurface water on the shelf. and it's related to coastal ocean circulation. So I will tell you what kind of subsurface water temperature has been recorded and why. And the takeaway point is the importance of coastal ocean circulation, coastal ocean observing systems. That's very important, need to be sustained. The, this analysis results, sorry. Okay. This analysis result has been published in the geophysical research letters in December last year. And also the results have been presented in an AGO4 meeting also last December. Coastal Ocean Circulation Lab at the University of South Florida, previously directed by Dr. Weisberg, Robert Weisberg. He was my PhD advisor and long-term supervisor here at the University of South Florida. We maintain a coordinated coastal ocean observing and modeling program on the Westward Shelf. And what I showed here is the modeling component. Now we have not only the WFCON with West Florida Coastal Ocean Circulation Model has been developed more than 15 years, and TBCON with river high resolution focused on Tampa Bay. Currently, we expand this effort to the East Florida coast. So we have EFCON, East Florida Coastal Ocean Model. And we maintain this model as an operational automated daily nowcast forecast models to provide one-day handcast and 3 and 5-day forecast. This example of the water level information extract from all these models, we combine with the tide gauge, provide coastal water level forecast information to the community. It was used in the last Hurricane Helene and Milton last year. This is a bit of divert, okay? And the observation component currently including 5 active stations. 4 of them are surface buoys, and 3 of them are subsurface moorings. So surface buoy mirrors the full meteorological set and water column velocity, ADCP, more at ADCPs, and temperature salinity at selected depths. All the, except for the subsurface temperature salinity, back then, the other data sets are delivered in real time. Subsurface data are delivered in delayed time. Yeah, we record once a year. So what kind of ocean conditions was in 2022 during Hurricane Ian event? What I showed here is a composite of temperature data recorded from this buoy, 3 surface buoy at the time. The C22 was shorter time, so we don't show here. We show here the record at C10, C12 and 13. C10 at about 25 meter isobase. 13 and 12 both located on 50 meter isobase. So I show this record, 27 years record on an annual basis as the gray lines. And the thick black line, that's the monthly mean climatology calculated from the long-term record. And thin black line shows the 90th percentile, where anything above that or above that line shows really enormously warm. And 2022 temperature shows as the red one. You can see that year the temperature was enormously warm, even at the surface. This is the SST. So when you take a look at subsurface temperature, let me spend more time on this because so much information is in this one. I still show the station's location map on the, to the right. I mean, starting from the right, the right column shows the subsurface temperature record at these shallow locations. C15, that's the 10 meter isobase. C11, 20, 20 meters is about C10, the surface width, but I showed here the near bottom record. C19, that's down south near Key West area. So this subsurface temperature at this shallow water was about still 1 to 2 degrees warmer than climatology. Okay, but when you look at the offshore locations, C12, I showed both 20-meter depths and 30-meter depths. I mean, at both locations. So you can see this surface water temperature was 2 to 3 degrees warmer than this climatology mean. And if you take a look at this C13, which is the the bottom left panel, I mean the warm temperature started in April. It lasted several months all the way through this August. Then that's the time we swapped the buoy and the new deployment, the sensor was lost during the Hurricane Ian. So you can see that the warm temperature throughout the entire summer. And if you look at 20 meters, which is the top left corner of that panel, you can see this temperature was above this 90th percentile a lot right before Hurricane Ian. That indicates this at the 50 meters offshore, this water subsurface temperature was really anomaly high. So why was temperature so warm? Okay, I will go through several factors which contribute to this enormously warm subsurface temperature. Here's the first one. That's a horizontal advection during hurricane event. You see that I showed here our model output during that date, the hurricane landfall date, basically also hurricane intensification date, because hurricane pacified this area within 1 day. So the top right shows as the R1 on that day, hurricane still located on the edge of weather shelf, probably still offshore. And then when the hurricane swipes through the southern part of the weather shelf, see the current patterns also, it's very complicated, but for the southern part of the weather shelf, the advection by the currents, you can see this downwelling pattern, surface water transported from south and west onto the weather shelf. Those waters supposed to be warm, okay, because transported from warm water region. And the lower left panel shows a subsurface bottom currents, because the current is so strong, so the entire water column have downwelling pattern. I mean, water transported towards the coastal areas. Warm water accumulate in the area hurricane will fly over. So for this factor, it's warm water. Okay. And another factor we should consider, that's vertical mixing. You know, if this hurricane, pacifies the deep water region, the water column is highly stratified in summer. In the deep water column, the water temperature usually are much lower, and the strong mixing could mix up this lower layer water and cool down the upper layer water very effectively. However, on this shallow westward shelf, you can see from satellite images, yeah, what sort of are the sediments, and your strong vertical mixing, you cannot bring any cold water from below. So sort of the sediments, not cold water. That's why it's so important to observe monitor the ocean condition for this wide continental shelf, because weather shelf the width of weather shelf is about equivalent to the loop current active area in the eastern Gulf of America. So it's so important. It's not a very shallow, not a very narrow shelf. So, but most people will know, okay, most of these hurricane monitoring programs are located in deep water. A lot of funding is spent in the Gulf, in the loop current area. And these shallow water are largely overlooked. Thanks SECOORA and IOS for providing this support to monitor the Western Shelf. Otherwise, we have nothing to show you today. Okay. So, yeah, another factor is the coastal ocean circulation. My expertise is really the coastal ocean circulation. I'm a physical oceanographer. So our insight is really the contribution from this talk and the paper is about ocean circulation. So loop current, they change all the time. The evolution is so complicated. The pattern change. It's hard to predict, and there's not obvious seasonal variation. So but it's so important. It could significantly influence Western Shelf circulation in a way that it's become a game changer. Okay, we have so many publications on this topic. Particularly if loop current interact with Western Shelf in the southwest part of Western Shelf near dry tortugas, we call this location as pressure point of the Western Shelf because it's so critical. The loop current forcing at this location, it could result in the enormously strong upwelling on almost the entire Western Shelf. The right pattern shows strong near bottom currents during the year 2010, where loop current this is a case loop current interaction with Western Shelf for a long time. See the strong currents on the Western Shelf. Cold water to be transported onto the Western Shelf from the offshore. So in this case, the shelf could be flushed. And warm water on the shelf could be replaced with cold water from offshore origin. So how can we get some information like this to help us to monitor the ocean circulation on the Western Shelf? Yeah, we did some analysis of altimetry data. Satellite altimetry has been available now for more than 30 years. We need to summarize what kind of patterns, how frequent this kind of patterns occur over time during the last 30 years. Yeah, so it's not easy, difficult. If you take those 30 years daily snapshot of patterns, it's hard to extract to summarize useful information. So we choose a machine learning tool which has been developed by computer science community a long time ago, now 20 years ago. That's the tool we use. Actually, I used for my dissertation 20 years ago. So it's called Self-Organizing Map, or for short as SOM. I'm proud to say that we are the first SOM users in physical oceanography. And those papers now become my top cited papers. And also those the famous current patterns on the Western Shelf analysis of the moored time series at the time is on the 3 years length by SOM. Those patterns, those figures have been included in the data analysis method in physical oceanography, a Bible in physical oceanography data analysis by Thompson and Emery. So some people can check that, but yeah, you can take a look at a paper if you want to know more about it. I won't spend more time on this. But here is a summarization of the patterns of loop current system for the eastern part of the Gulf. It shows the interaction of the loop current with the Western Shelf. So 30 years of satellite altimetry data now summarized in these 20 patterns. And the occurrences over time can be shown in the bottom, which this time series show which pattern were seen and how long they lost over time. So basically, you see the current patterns change from pattern to pattern over the time during these 30 years. It's very, I mean, it's a dense time. The time is very long. So you see a lot of, so it's not very clear from this map show exactly where they're gonna look like, which pattern, when which pattern occurred. But if I zoom in 1 year, for example, the year of interest, 2022, those time series shows clearly the relevant patterns as shown in those in these purple boxed patterns, which shows the interactions of the loop currents is a pressure point. So the relevant patterns for strong opening on the weather shelf. Those patterns didn't occur during most of the time of the summer to the spring to summer time of that year. It's briefly occurred in later July. You see the in the middle of the bottom plots. But that's it. It won't flush the weather shelf effectively because it's too short time. I mean, the message takeaway from these two slides is loop current didn't flush weather shelf. Okay, during 2022. Then the water left on the weather shelf just heated by the sun, by the the atmosphere, and that's caused enormous warm water on the weather shelf, the subsurface water. And the surface water, you cannot see that because it was not much different from the satellite observed SST, but subsurface water a lot warmer. Here, I show the entire record of the 30 years of altimetry data, shows the interaction of the loop current with the weather shelf. I highlight the 3 time periods. The 2022, I already showed you, okay? That's the case for Hurricane Ian. Now, the other 2 cases, year 2000, I showed as red because that year, loop current interaction didn't occur. We didn't see any of those blue bars, which shows the interaction. Another case, 2010, highlighted as a blue box here, shows the persistent, that's a protracted loop current interaction with the for the majority of that year, majority months of that year, starting from early summer. So during these 2 cases, the top panel shows year 2000 without loop current forcing. The bottom one shows the year with loop current forcing. What I showed here is the time series temperature at surface and subsurface. The two lines, the blue line shows surface temperature, the red line shows subsurface temperature. We see that the stratification between these surface and the subsurface layers, the temperature difference is about 3 to 4 degrees when there's no loop current forcing. Basically, current weather shelf is not touched by this offshore forcing, so it's no strong upwelling. But during the case of strong forcing, you can see this stratification became much stronger. The temperature difference now increased to 8 to 10 degrees. So the subsurface water much colder than climatology. But without forcing this 50 meters per cc, even subsurface water is still warmer than monthly mean climatology. Let's take a look at another location, shallow water. Okay, 25-meter isobase. This is C10. So with loop current forcing, without loop current forcing, the top panel shows that the temperature is almost well mixed throughout the year. Not much stratification because water is so shallow, 25 meters on the inner shelf. So temperature, those near surface, near bottom temperature, not much different. Okay, unless you focus on this daily time scale. Yeah, they are different. But for this, in the case of a strong loop current forcing, the cold water was flooded here to this shallow water. You see, the temperature is about 6 or 8 degrees colder than surface. You know, subsurface water was much colder by about maximum about 8 degrees. So in the case of strong offshore forcing, this cold water from the offshore origin could be transported across the shelf all the way to the inner shelf. Okay, the entire shelf was flooded. Implications for this hurricane intensification. Okay, so coastal ocean circulation plays an important role, changing the water properties. When the loop current without loop current forcing, so the I showed you Hurricane Ian case, the shallow water could be enormously warm. However, with protracted loop current forcing, then the shelf water could be cold in summer, which may not facilitate rapid intensification of hurricanes. See how important, I mean, this loop current system played a major role in setting the water property on the western shelf. I want to briefly summarize what I talked about so far. It's the rapid intensification of Hurricane Ian was related to enormously warm surface water on the western shelf, which recorded by the long-term record, moored record on the western shelf. This highlights the importance of subsurface temperature monitoring in the shallow coastal oceans, which is largely overlooked in these hurricane-related ocean heat content observation programs. So the absence of the protracted loop current interaction with the shelf pressure point location during the summer of 2022 resulted the enormously warm water on the western shelf, and that could account for this rapid intensification of Hurricane Ian in that year. So the implication is for better prediction of hurricane intensification, it's important to understand the coastal ocean circulation dynamics. Okay, coastal ocean is very different from deep ocean. Those not only these dynamics, how the water is mixed, also very different. And it's important to maintain the full water column real-time observations of shear circulation and temperature. So particularly, we need to put limited resources to these dynamically important and scientifically justified locations. Another thing, I will talk about the hurricane modeling part, but I know not every hurricane models use the subsurface water temperature. I know those SST is widely used, and I know most those hurricane models use SST for their the forcing from the ocean. Okay, surface water temperature should be considered, and even better to include the full ocean circulation in the coupled model. Okay, but how to improve the hurricane intensification forecast? We need data, not just models. Okay, data is so critical. Without data, you just can know anything about the subsurface. So the IO supported the coastal ocean observation system need to be sustained without interruptions. The long-term, just 27 years long-term sustained record is essential in accurately calculating this monthly mean climatology. Without those long-term record, we just cannot know accurately the climatology, and then we don't know how anomalous. If you have measured, you go to there, with any measurement, deploy CTD or shorter observations, you don't know how anomalously warm or cold just those temperatures compared to climatology. So yeah, I'll stop here. Thank you for your attention. Thank you.
Well, thank you, Dr. Liu. That was a really insightful presentation, and luckily we have plenty of time for questions. So to our viewers, if you would like to raise your hand to ask a question, I can definitely call on you and then you can ask the question verbally. Or if you are more comfortable typing your question into the chat, then I can read it out loud and then we can address it. So we'll just take a minute for y'all to think about some questions for us to address. We've got plenty of time. All right, so we've got a question already. This is from Bella Dubois. Hope I pronounced that right. And it is in the chat. Are resources available, such as the subsurface buoys and subsurface moorings, to obtain data and investigate other hurricanes or tropical storms?
Let me see. Sorry. Let me see the chat box.
If you hit stop sharing, then you'll be able to come back and see the chat box.
Other hurricane. Yeah. Yes, we have on the Western Shelf. I know we have 27 years of time series. Yet we have some data to investigate other hurricanes and tropical storms in our region. Yeah, this Hurricane Ian just occurred last year, 2 years ago, and we have recent hurricanes, Hurricane Helene and Milton. We're gonna analyze those and previous hurricanes as well. We just need some time. Yes, we do. Yeah.
I'm actually going to put a resource in the chat. This is our hurricane data portal underneath SECOORA that has historic hurricane research on there. So does anyone else have any questions?
Yes, thanks, Bella, for the question.
All right, we have another question in the chat. Are there any other examples or evidence of the absence of protracted loop currents contributing to the intensification of other hurricanes?
Okay, that's a very good question, Natalie. Can I share my screen again? I want to show you something.
I can still see your screen, so you're still sharing.
Yeah, please. Let's go back to the last four. Counting from the end, that's the fifth one. The time series about. Can you? Oh, let me show that. Stop sharing. Oh, I still share my screen. Okay.
Yeah, we can still see your presentation. It's just on the PowerPoint view.
Okay. PowerPoint view. How can I switch to back to that one? Point view. Okay, got it. So, and now you see the time series of the monthly time series that plot.
Yes.
Okay. Here, just for example, recent 4 years, starting from 2022 Hurricane Ian, 2023, 2024, those blue bars didn't raise. That means these years, recent 4 years, the Western Shelf was enormously warm. I mean, not only 2022, 2023 Hurricane Idalia occurred, that's made landfall on the Western Shelf in the Big Bend region. In 2024, we have 3 hurricanes, Hurricane Davy, which is category 1. Then Hurricane Helene made landfall again in the Big Bend region on the Western Shelf. And Hurricane Milton, are so destructive, those hurricanes. All 3 hurricanes occurred in 2004. Yes, these are due to the case with there's an absence of loop current with the Western Shelf. I think so. Natalie's question is about the evidence of absence of protracted loop current contributing to the intensification of hurricanes. This what I showed here will be the starting point for future data analysis. Okay, data has been archived on the for the weather shelf. We just need a bit of time to take a look. There's any cases hurricane not intensified during the years with strong upwelling. No, we have time series shows all those which years during the summer time we have this upwelling. 2010 I showed you, and 2016 and 2020 could be other cases. Or take a look at it. Yeah, this a lot of work to do, Natalie. Yeah, we will know more about that. Yeah, we can start from this time series. Yeah.
All right. Does anyone have any more questions? Remember, you're welcome to raise your hand and verbally ask the question, or you can put it in the chat for us to read out loud. And I do have a couple of questions that I can ask as well, if nobody else has any additional ones to add, or I can give y'all a second to think. So my question is, can glider data provide enough information about the subsurface temperature in coastal oceans?
Very good question. Yeah, glide data is a very useful tool. Observe is water temperature salinity profiles throughout water column, and they can form transects and have very useful information for certification. But glide data just like a ship-based cruises, they provide only transect for a certain time. You still need long record to establish this long-term climatology, so that you know how enormously warmer or colder your glider mirror temperature in the context of. I mean, you cannot tell from glider data itself how warm or is colder than mean, or is warmer or colder than monthly mean climatology. So we still need more observations. So the coastal ocean observations, why we need different platforms, because different platforms provide different information. Yeah. Thank you.
Yeah, thank you. Now, does anybody else have any more questions? And you're also welcome to email me any questions, and then I will connect you with Dr. Liu to be able to answer those appropriately. Dr. Liu, do you want to go ahead and put your email in the chat so people can connect with you if they are interested? Okay.
Yeah.
Perfect. So his email is now in the chat if y'all want to talk to him directly. All right. Well, it seems like we don't have any other questions. So Dr. Liu, do you have any parting words of wisdom that you would like to say before we close?
I would say I want to thank you guys again, the SECOORA and IOS, for sustained support over the last 20 years on the Western Shelf. The more observations, so critical, and I hope this program can be sustained in the future and continue to provide important information for this hurricane rapid identification forecast applications. So I know it's a lot of uncertainty regarding the future of the program, but I really hope this program can be continued. Thank you. Yeah.
Thank you. I'm really glad that you could come on today and give a webinar on this really important information. We have Deborah Hernandez, our director, in the chat saying thank you, and we appreciate you so much and your team at USF. As a reminder to everyone, this is recorded and it's going to be on our YouTube channel. I'll be sending that link out to everybody if you would like to share it with anyone who couldn't join us today. So I just want to say thank you everyone for tuning in. Thank you, Dr. Liu, for this wonderful presentation. And I hope everybody out there can stay positive and stay passionate about the work that we do.
Thank you.